Alright guys, so this video might be a little bit long, but I promise you the material is very easy. So let's get going. We have three stories that carry TVs, laptops, and phones. Story 1 carries 5, 4, and 5 of each of them. Story 2 carries 6, 7, and 1 of each of them. And story 3 carries 8, 2, and 2 of each of them. So our goal is to really take the information given in this sentence or in these sentences and put them in a neat and ordered way. So pretend I was using Excel. How would I put this information into Excel? Well, I can make rows that are of the stores, and I can make columns that are of the items that are being sold, right? So we've all used Excel before. We've all probably made some sort of spreadsheet or some table like this before. So this is representing the above information. Okay, so how about if we want to graph this information? Well, we can graph this using something which might look a little complicated, but I promise you it's not. Something that looks like this, where we're using a three-dimensional almost plane. And let's see, how can I explain this? Well, here, store 1, see this blue point right here? It says store 1. Its coordinate, its x-coordinate would be 5, its y-coordinate would be 4, and its z-coordinate would be 5. So I can plot all of these points here, and they each represent the number of TVs, laptops, and phones in each one of the three stores. Okay, what's another one? Well, if you guys have taken any sort of Python or done any kind of computer science, you know that in computer science we store information using these things called arrays. So that's another way we could also store this information on a computer or using a computer. But the big question here is, how do I write this information in mathematical notation? So that's when these things come in handy, these things called matrices. So what is a matrix? Matrices are a mathematical way of representing pretty much a list. What do we have here? We just had a list of stores and a list of items that the stores carry and how many were in each store. So that's all that matrices really represent. It's just a list of items. More formally, a matrix is a rectangular array of numbers where the numbers in an individual row are related to one another and the numbers in an individual column are somehow related to one another. So for instance, if we look at our matrix right here, each row, what does each row represent? An item being sold in the store. So it's what? TVs, laptops, and phones. So they're all of them are related. Each column is related by that instance. And each row is, how are they connected? They're all related because, well, this is store 1, this is store 2, and this is store 3, right? So there has to be some sort of relationship between the columns and the rows. Okay, so notice how when we talk about matrices, it's a rectangular grid of numbers, and this one happens to be a square, but usually it's some sort of rectangle. It has these big parentheses around them, and they're usually called some capital letter something. So for this one, it's an uppercase A, right? So this matrix, we would just call him A, uppercase A, that is. All right, now I told you that we can label each column is related somehow, and each row is related somehow, right? This was store 1, store 2, and store 3, but we could have easily written this as the other way around, right? So I could have switched. The columns could have represented the stores, and the rows could have represented the items being sold. So you can write them either way. It really doesn't matter. It's up to you. It's only going to matter once we start doing matrix multiplication, really. But if you have a question like the one we started this lecture off with, go ahead and feel free to use whichever you want. Okay. So if you have a matrix that's defined already, so you already told me that A equals, the first row is 5, 4, 5, the second row is 6, 7, 1, and the third row is 8, 2, 2. If I do choose to use or reference this one where I switch their rows and their columns, then the matrix that switches the rows and the column of A is called A transpose, and it's usually denoted by this A to the capital T. So A transpose is A, but all the rows and columns are switched around. The only thing you'll notice is that the diagonals stay the same, right? And everything else switches, like the 6 and the 4 switch, the 8 and the 5, and the 2 and the 1, they all switch. But the big picture here is that if you're talking about A, if you want to flip around its rows and its columns, you're going to have to call them A transpose. Okay, so right now we're just really getting like all the names and stuff out of the way, nothing too difficult just yet. Okay, so how many rows and how many columns can matrices have? Well, remember, matrices are just a list of items, so you can make a matrix as big as you can make a list. They can be as big as you want. So there's no limit on how many rows you can have or how many columns you can have. But there is a standard on how we state the number of rows and the number of columns. See, we always say the number of rows first, and then we state the number of columns. So for instance, oh, maybe I should say, so the row, when we talk about the row and then the column, we're pretty much talking about the size of the matrix or the dimensions, right? It's like if I have a rectangle here, right, and I'm talking about its length and its width, and let's say it's like a 2, it has a width of 2 and a length of 4. We could just call them like a 2 by 4. It's the same thing for a matrix. If we're talking about the dimension or the size of the matrix, it's the rows. So for here it would be 3, and by the number of columns, which is 3. So this would be a 3 by 3 matrix. So we'll do some examples real quick. Here's the one we were just talking about. This is a 3 by 3 matrix because there are 3 rows and there are 3 columns. Remember, this guy represents rows and this guy represents columns. Anytime you have a matrix that is n by n, meaning the columns match the number of rows, we say it's a square matrix because they're the same length, right? Just like a square. A rectangle with equal sides is called a square. Maybe it's, I don't know if that's true. Well, if it's equal sides and they have 90-degree angles, right? Maybe then it's a square. Okay. Here's another one. So this is matrix B, capital B, and let's figure out its size. Well, it has 1, 2, 2 rows, and it has 1, 2, 3 columns. So we say B is a 2 by 3 matrix. All right. All right, last one. In this one, we have B transpose. So B transpose has a size of what? Well, it has 3 rows, and it has 2 columns. So B transpose is a 3 by 2 matrix. And this kind of makes sense because let's compare B and B transpose. Remember, the difference between B and B transpose is that you just switch their columns and their rows. So obviously these numbers right here are just going to be flipped around. Hopefully that makes sense, right? It's pretty intuitive, all of this stuff. Alrighty, let's see what else we got. Alright, so now we're going to be talking about the entries in the matrix. So each individual value in the matrix. Now, how do I reference each of these individual values? Well, I can easily just say, well, 7 in matrix A, and I would be talking about this guy right here. However, the problem with this is that if I choose to say 5 in matrix A, I don't know if I'm referring to this guy or if I'm referring to this guy. Same thing as if I say with 2 in matrix A, I don't know if I'm talking about this guy or this guy. Which one am I talking about? So we have to have a good standard on how we go about referencing these guys. And here's our standard. So first of all, each thing in the matrix is called an entry or an element. And we kind of follow the same standard when we were talking about the size, where we talk about the rows, then columns. But let me take you through this first. So each element or each entry in our matrix looks something like this, where A is the lowercase of the name of the matrix. So our matrix's name was capital A. That means each element will be a lowercase a. And then it's always going to have these numbers attached to it. This first number represents which row this value is located in. And then this second number is going to tell us what column that this number is in, right? So this element that we're looking at right here, this element or this entry of A is located in row 3, column 2. So let's just take it back to this guy. Where's row 3, column 2? Well, Jesus. So this is row 3, and this is column 2. So A, 3, 2 is talking about this guy right here. Alrighty, good. Pretty straightforward so far. Nothing crazy. Big thing here is, of course, notice how, again, just like when we were talking about size, it's always rows, then columns, rows, then columns, rows, then columns. That's probably the biggest mistake most kids make, students make when they first learn linear algebra or matrices and stuff like that, is they switch the rows and the columns. Always talk about rows first and then columns. The way I like to remember that in my head, it might work for you, it might not, is that like when you're building, I can't remember the names of those buildings in like Greece, but anyway, you know the thing that the Lincoln Memorial was modeled after. You know, you build the floor of a building first, and you have to have an idea of where the ceiling is before you start building the columns that connect the two. So that's how I picture it in my head. You got to think about the rows, meaning the ceiling and the floor, before you can think about how large you want the columns to be that connect the floor and the ceiling. I don't know if that helps you guys, but my weird brain, that's how I think about it. Okay, let's see. Okay, so moving on, or I should say continuing, that means all of the entries in a matrix can be referenced like this. This guy is in row 1, column 1. This guy over here is in row 2, column 3. This guy is in row 3, column 2, right? So you guys get the picture. Rows first, then columns. And if my matrix name was B, capital uppercase B, then all the elements will have a lowercase b as their name. Okay. I feel like I skipped something. Oh, I guess I didn't. All right, so matrices of the same size can be added or subtracted. So if a matrix has size mn, and matrix B has the same size, mn, then you can add them together. And when you add them together, what you're going to do is, what you're going to do is you're going to add all the corresponding entries. And that might seem confusing at first until we come to this example. But one thing you should note is that if matrix A is size mn and matrix B is size mn, then you are allowed to add them. If they're different sizes, you cannot add them. The other thing is this, their outcome, so a matrix plus a matrix will be some other matrix. That matrix will have a size that is the same as the other two. It will also be mn. All right. So let's go ahead and let's look at this. Next question here. Matrix A is, let's see, 1, 2, 3. It's a 3 by 1, 2, 3, 3 matrix. And matrix B is a 1, 2, 3, 3 by 1, 2, 3, 3 by 3 matrix. So A and B both have the same size, so we're able to add them. Because we're able to add them, what is the size of the resulting matrix? Well, it should also be the same size as them. So their outcome will also be of size 3 by 3. Okay, so remember what I said here. I said each, oh, I didn't put CIC. It's okay. So how do I find the values or the entries for C? Well, what I'm going to do is I'm just going to add the same, so like the top left entry is added to the top left entry here. That's where I get 5 plus 1. The top middle entry is added to the top middle entry here. That's where I get 5 plus minus 2. Then so on and so forth, right? The middle entry is added to the middle entry. That's why I get 7 plus minus 5. So you're just adding the corresponding elements. And once you do that, you can simplify down to something like this. And this guy would be our resulting matrix, which is 3 by 3. Not bad, right? So when you add a matrix, just add the corresponding entries. So that's where this guy comes in. You said you're doing A11 plus B11, and that's where you found 6. Hopefully that makes sense to you guys. Pretty straightforward. I gotta stop saying that. Anyway, here's another example. So this time what we're going to do is we're going to be subtracting them. You're going to do the same thing, right? You're going to take this top left guy and subtract from him the top left guy over here, which is how you get 1 minus minus 5. You're going to take this guy right here, and you're going to take away from him this guy, right? The matching entries. And you're going to do this for every single entry. So you're going to do it 9 times. Do it for every single one. I did one which was addition and one which was subtraction because I want to point out the most common mistake here that students make. And it comes down to this right here. When you have 2 minuses, don't forget, it makes a plus, right? So you'll have a plus here, and you'll have a plus here, and you'll have a plus here. So just be careful of that, guys. Hopefully you guys can see how this leads into this matrix result, C. Okay, I had another question here, but I decided we're not going to do that one. Let's go into the last thing of this video. So matrices can also be multiplied by some scalar constant, where they pretty much just scale all the entries. So here I have matrix A, and you see how it's denoted normally. What happens in the right hand side is if I multiply A by some real number k, then I'm going to take every single entry and I'm going to also multiply it by that same real number. So for instance, if I'm given A equals this, then what is 3 times A? Well, all I'm going to do here is because I'm multiplying by the real number 3, I'm just going to multiply every single entry by 3. And then my result is just going to be, sorry, I meant to highlight that when I was making it, but it didn't work out. And then you would just multiply all these 3's to your corresponding entry and you would get your result. Like I said, these are all, nothing what we're doing in this section is very hard. It's just there's a lot of things you have to know. Okay, and the same thing happens if we multiply by, I don't know, let's say minus 2, right? Then each entry is going to be multiplied by minus 2, 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 and you'll get some output. All right. So minus 2 times 5 is minus 10. Minus 2 times 4 is minus 8. Minus 2 times 5 is minus 10, and so on and so forth. All right, I know you guys are pretty smart, so I think you guys got this. I know I went over it pretty quickly, didn't spend too much time on anything. If you want to do a question on your own, here's a good one. I didn't go over it, but there might be something like this on your homework, so take a look at that. Here's the solutions. I think you guys will be fine.